I'm going to show you how to make the second degree hand by David Orgeman. The design looks like this. It's good for recipients that have a thumb but is missing fingers or only have residual fingers. The design is modified by me and Sean, another member of the e-nable community. We remade the design so it have fewer parts and made it a bit more simple. We left a lot of room for the recipient's palm, and we also made a tensioning screw so you can tighten the palm strap like this. I will guide you through all the steps necessary to make the hand, the scaling, printing and assembly. To make this design, you need some basic tools, you need some softwares, OpenSCAD, Fusion 360 and Prusa Slicer. You also need some PLA filament and a 3D printer. The complete bill of materials will be available in the video description. We will start off by taking some reference photos. In this case, we will use my hand as an example. So my left hand will be a disabled hand and my right hand will be fully functional. To take some good reference photos, you need a flat tape measure showing 100 millimeters. You need a permanent marker and your mobile camera. Start by putting a dot in the middle of the wrist joint from the side. Put another one on the top side. Put the tape measure as close as possible to the arm and make sure that the knuckle line is perpendicular to your arm. Take a photo from straight above. Take another one from the side. Take a picture from straight above of your right hand. Here you can see all the files available in the video description, together with the 3 pictures we have just taken. If you open the SCAD folder, you will see a couple of OpenSCAD files. OpenSCAD is the CAD software this design have been designed in. If you're unfamiliar with OpenSCAD, it's a programming-based CAD software. Let's open the hand parameters SCAD file. You can see in the editor window to the left that there's a lot of parameters that needs to be filled in. We are going to use the reference pictures to take measurements and then transfer those values into OpenSCAD. And with those we get the correct scaling of the models. To make measurements in the reference pictures, we are going to use Fusion 360. Begin making your reference model by putting in the reference pictures as canvases. Place this canvas on the top face. Zoom in and calibrate the canvas. Click on 100 millimeters and type in 90. We want to scale down the picture because the tape measure is a bit further away than the top of the arm. Now the picture is scaled to the right size. Go in and edit the canvas. Show origin. Move the canvas so that the dot on the top side of your arm is in the middle of the origin. Rotate the picture so that the x-axis is in line with the arm. Hit OK and let's place the side canvas. edit the canvas, rotate it so it has the proper rotation. Let's calibrate this picture. It seems like this is aligned well. Hit OK. Let's hide the origin again and name the pictures. Let's take some measurements from the canvases. We need the knuckle width. It's approximately here to here. Round up the value you see and type in 80. We need the wrist distance from here to here. We also need the knuckle distance, which is from the wrist joint center to where the knuckle hinge will start. It will be somewhere here. The gauntlet length is from the center of the wrist joint and goes back 120 millimeters. From that point, we want to measure across the arm. 65. Now we have all the measurements we need from this side. Let's activate dimensions. Let's take some measurements from the side view. We need a wrist thickness. And we need the arm thickness at this distance as well. Name the sketch. And show the dimensions. Save the file. Make a new design for the right hand. The same procedure goes for reference picture 1, which is the right hand. This picture doesn't have to be centered or lined up. Let's put a sketch in this one. Measure the fingers by putting some lines between the knuckles. Round up the values. Do this for all the fingers. We can rearrange the dimensions so we can see them a bit better. Like this. Save the file. Next step is to make a mock-up of the hand that will be used in the virtual assembly. We can hide the sketches and put a new sketch on the top side. Try to follow the contour of the arm with the spline tool. We want to create a smooth curve as possible. Okay, let's connect the dots. Finish sketch. Make a similar contour line from the side view. In this case, the left hand doesn't have any fingers. We will have to come up with some shape here. Let's try to extend this end a bit further than the point you can see here that is coming from the other sketch. We want to overlap those two. Remember, we want to try to keep the curvature as smooth as possible. Okay, I'm happy with that. Let's finish that sketch. I forgot to close the end. Now we're going to extrude those faces. Let's start with top face. Make a symmetric extrusion. Pull it out. And make an extrusion for the side view, symmetric, pull it out and choose intersect. Okay, now we have a basic shape of our hand mockup. Let's try to make this a bit more organic and round. Make a fillet and use the variable radius option. Add new selection of radius point and choose where you have the smallest curvature. I think it's here. Type in and try some radiuses. If it doesn't work, maybe you have to go back into the contour lines and make them a bit more smooth. Okay, I'm happy with that. Let's make the same for the other side. We want to have a reference point in the middle of the wrist joint. Let's make another sketch on the top side. Hide this body and show the top view. Make a small circle here. Finish the sketch and can then cut through this body. Okay, now we know where the center of the wrist joint is. We also need to make a cylinder shaped feature that is sticking out of this hand. This will become evident later when we do the virtual assembly. The last thing we need to do is to make a measurement of the circumference of the palm. So make an offset plane. Put this offset plane in the middle of the palm. Make a sketch on this new face. Do a section analysis of that construction phase. Okay, back to this sketch and make an ellipse in the center of this section. I think something like this is good enough. And now we can inspect and measure the circumference of that ellipse. Okay, now we have all the measurements we need. we have a hand mock-up, and we got a palm circumference measurement. Then we're ready to go into OpenSCAD and input all the measurements to generate the hand models. Make the measurements visible and hide the body. The knuckle width 80, but we will make this a bit smaller because I know that this script tends to make the geometry of the knuckle block a bit too wide. So I will lower that intentionally to 75. The wrist distance 118. The proximal measurements will we find in this sketch. The distal measurements are not currently used. The pivot width is the wrist width plus 5 mm. Let's go back. So I think we measured 53. So that'll be 53 plus 5. The wrist thickness 40. Okay, now we have transferred all the values. We can save the hand parameters file. We can now open the other SCAD files. By clicking on render, a file is generated. We can now generate the STL file. Let's save this under the STL folder. Do the same for all the files except hand parameters, helper modules and metric sizes. You can open up all the files and render them at the same time. If you want to change the values later, you will automatically get the new preview in the other files if you hit save. Okay, but for now let's stick with 75 and generate STLs for all the components. I'm seeing in the finger geometry that we have some artifacts sticking out here and that this proximal is a bit too short. So let's go back into the parameter file and make the pinky intermediate a bit longer, as well as the pinky proximal. Okay, now I think it's fine. Let's also name and export this hand mockup. Now that we have all the STL files, we can start doing the virtual assembly. Import all the OpenSCAD files and the hand mockup except the finger file. We can split the gauntlet to objects. Let's remove these small pins. Okay, now we can start doing our virtual assembly. We can now cut off the cylinder that we made. Okay, I think this looks fairly well. We have some interference here, but I think won't be an issue because this bone going here is quite flexible. If you notice any other interferences or that something is improperly sized, you might have to go back and put in some new parameters. Then you have to re-render and rebuild your virtual assembly. We can now go ahead and prepare our G-codes. So these two parts doesn't require too much detail and can be printed at about 0.3 layer height. So we will prepare those two together. The gauntlet will be printed on this face, and the main cuff is fine as it is. For these two parts we will use supports, and we will have the draft preset and add some parameters and perhaps some infill as well. Let's try to slice and get a section view of this part. Okay, I think this looks good. We're missing the support. Let's add that again. Okay, let's export that G-code. Remember that we need these small pins. We're going to remove the gauntlet, the cuff, and all pieces left are necessary. This one is going to be printed on the other face like this. Otherwise, I think we're ready to print, but we will add support on build plate only in this case. This is very important because we don't want any support materials in the small holes everywhere. And let's print this in quality settings. Sorry, let's add that again and add some parameters, bump up the infill and pre-slice. Export the G-code. Okay, now we're ready to print. Thank you so much for watching. Now go ahead and print your parts, and I will be back in the next video to show you the assembly procedure. Take care.